All right, so 9 is going to take some time because line has a lot of things going on. We're going to try and make this in a form of A absolute values of B times x minus h plus k. What we're going to do is we're going to factor a 2 out. We're not going to factor out the negativity. That'll screw things up. If I pull a 2 from that, it's negative x. If I pull a 2 from that, it's minus 3. And then we have the plus 3 that's staying there. Now I need this b term. The b term happens when you pull a negative from both pieces. That's my phone going off. That's taken care of. All right. So what this is this is a horizontal reflection. This takes a V, and if you, I wish I could show it on a piece of paper, but if you horizontally reflect it, you still get a V. It's kind of doesn't matter. All right. That's a big thing. The rest of this you're comfortable with. We're going to go left 3 and up 3. I'm going to put us right here. We're going to have an initial slope of 2. Rise 2, run 1. Rise 2, run 1. If I was using grid paper, I probably wouldn't do any algebra. But hopefully what you see here is you actually have 2 distinct, not quite lines, but we'll call them lines. Lines go on forever and ever in both ways, but you have 2 distinct lines. And you're going to write the equations for those lines. You're probably like, Milbrath, is your graph right? Like, I don't trust all this by hand stuff. That's valid. Reflections give me a headache too. Let's see what Desmos says. Does Milbrath agree with Desmos? That was absolute value, negative 2x minus 6. And then plus 3. Well, that ought to shut you up right there, right? Turns out I do know what I'm doing. Looks exactly the same. 3, 3, rise 2, run 1. Let's just go ahead and use Desmos real quick to check myself. I should be getting a y-intercept of 9 over here, okay? That'll come into play later. But I do have 2 distinct lines. So I need to write some equations to those lines, and I don't have grid paper, so I'm just going to go back to doing some algebra. It's a 9th grade math standard. 9th grade is when you learn point slope form. Point slope form was y minus y1 equals m times x minus x1. Now on my slope, here's my slope, it's 2. That's known. I've got a point too. I had a point right here. What was that? That was negative 3, 3. So that's my x1s and y1s. I just got to plug crap in. Y minus 3 equals a slope of 2 times x minus negative 3. Taking away a negative has been addition forever. And now I can use the distributive property. 2x plus 6. And then I'm going to add 3. Y equals 2x plus 9. Notice I went on Desmos and I said, let's check that y-intercept. It was 9. Now, that's one equation. The other equation doesn't have a positive slope. Then on this one, the slope is negative 2 because it's going downhill. So we're still going to do point slope form. Still going to use the same points, y minus 3 equals, but this time we have a slope of negative 2, and then x minus a negative 3. Again, taking away negatives addition. Negative 2 times x is negative 2x, negative 2 times 3 is minus 6. Still going to add 3. And we get y equals negative 2x minus 3. Now all you have to do is talk about domain. One of these things was valid when x was less than negative 3, and one of them was valid when x was 3 or more. You really have a choice on where you put the inequality symbol. The equality symbol, it doesn't matter. It really doesn't. This is called g of x. Big old curly brace. One of these things was valid when values were less than 3, and the other one took over at 3, and I'm going to say 3 or more. Doesn't matter which one of these gets the equal symbol. One of them has to have it, but not both. For the commas, top one, where x is greater than, that should be negative 3, shouldn't it? When x is greater than negative 3 was the 2x plus 9. When we were less than negative 3, I did that backwards. Forgive me. Got in a hurry. When I was less than negative 3, I was this guy over here, which is that equation. Negative 2x minus 3. And when I was greater than or equal to negative 3, I was this one, the first equation I wrote, 2x plus 9. Yeah, those are rough. A lot of math required. A lot. I like them. You probably don't. There's a shortcut to this too. Maybe you can kind of look at the numbers. Negative 6 plus 3 is minus 3. Positive 6 plus 3 is 9. It exists. Let's see, what was the goal on this one? The goal on these was to state domain and range. Some people can look at these things. I can now. And some teachers teach, just look at them. Just look at them. I think those teachers think that everybody can look at things and visualize right from the get-go. Just because they can, they've forgotten that once upon a time they had to graph. But so I don't expect you all to be able to do that. I really don't. Anyways, I'm just going to do some rough graphs. That's what I'm going to do. This says x minus 1 if x is less than 1. So if I plugged in a 0, I would get negative 1. I put a hole there. If I plugged in a negative 1, I would get negative 2. If I plugged in a negative 2, I would get negative 3. This is doing that. It's getting smaller, all right? I'm 2 if x is 1. And I put that in the wrong spot, man. If x is 1, this thing returns 0, doesn't it? Open hole. If x is 0, this thing returns negative 1, and then it just keeps falling. It looks like that. I'm 2 if x is 1, so that means there's a solid dot right there. And if x is 2 or more, notice there's a gap. I'm 3 minus x. So if x was a little more than 2, if x was 2, I'd have a 1 back, and it'd be open hold. If x was 3, I'd have a 0. And if x was 4, I'd think 3 minus 4, negative 1. I'd look like this. This thing is funny. You talk about its domain, it's got gaps. There's a gap here. There's literally nothing between 1 and what? 2? So that's kind of funny. But it runs left forever all the way up to where x is 1. So the domain is negative infinity until we hit 1. And I get to be 1. There's a solid dot. There was an open dot here, but there's a solid dot there. And then I make this jump to 2. Union with 2 to infinity. Now the reason I have a parentheses on the 2 is because of the open hole. What's that look like using set builder? All values of x such that x is less than or equal to 1, comma, x is greater than 2. That's what it looks like. The range is also funny because we have a jump here. We have a gap. Actually, we have more than one gap, don't we? We go from, no, we don't. This, even though there's nothing here, these y values are covered there. We rise from negative infinity all the way until really close to 1. And I could see kids having issues with this. And then we have this solid dot up here just sitting there. Union with y is 2. Really weird. And again, that's a parenthesis. Set builder will be funny. All values of y such that y is less than or equal to 1. And then we have 2. That's it. I guess we should say y equals 2. Make it more obvious. One of the advantages of set builder is that it actually mentions the variable. Intervals do not. You might put in the word and y can also be 2, something like that. Rough drafts are where it's at. You have to visualize. You just have to visualize these things. I can look at this choice 4 here and I can tell you the domain pretty quick. I'm allowed to be less than -2, -2, and then I'm allowed to be 1 or higher, union with 1 to infinity. The range, I probably need to be plugging some numbers in. I really do. So again, I still encourage you to be visualizing. If I plugged a -2 into this thing, it would return 0. But I'd have to open hole it, no equality. And if I plugged a -3 into it, it would return -1. And it would continue that pattern for all of eternity. If I plugged a 1 into the second equation, it would return 5. And maybe you can see the slope is rise 1, run 1, but if I plug a 2 in, it returns a 6. And it would continue that pattern for all of eternity. That's what it would do. Oh, by the way, speaking of set builder here, all values of x such that x is less than -2 and x is greater than 1. You don't have to have the word and, it's optional. Your range, you go from -infinity to 0, and then you start off with a y value of what? That was supposed to be open hole 4. No, 5. And you rise until you hit infinity. Your set builder would be all values of y such that y is less than 0, comma, y is greater than 5. There's that. I got enough time to do the ACT. I got 6 minutes. I probably do not. So I'm going to stop this. I'll do ACT another day.